Hi, in this video, we are going to solve this combinatorics problem. Here we have to count the number of positive integer solutions of this equation. X plus y plus z is equal to 2010, but there is a condition attached to it, which is x should be less than y and y should be less than equal to z, right? So the total number of positive integer solutions for this particular equation, right? Now, you might have been aware of the stars and bars method. The stars and bars method is a way to find the number of solutions of equations like this. X plus y plus z is equal to n. Here the number of variables could be even r variables. Right now r is 3, right? So usually the way we do that is we say that to divide n into these many buckets, you can, or these many groups, you can take two bars, and there are n stars and two bars, and the number of ways of arranging them would be n plus 2 c2 in this case. But that kind of solution basically accounts only for the cases where x is greater than equal to 0, y is greater than equal to 0, z is greater than equal to 0. So that doesn't take into account conditions like this. Okay. If you're unclear on the stars and bars method, you can go to my channel and find combinatorics playlist, and in that I have explained this in detail. So if you go through the playlist on combinatorics, you should be able to find videos which talk about it. So hopefully that you already know, or you will be able to figure out yourself. Right now we'll go ahead with this question. So first thing that we do here is find the total number of solutions. Total number of solutions to this equation, to x plus y plus z is equal to 2010, given only the restriction is x is greater than 0, y is greater than 0, z is greater than 0, right? This is the total number of solutions. Obviously the answer for us will be a subset of these solutions, right? Because our condition is much stricter than this condition, right? So this is easy. We always, actually I have made a mistake here. We need positive integer solutions, right? If we want positive integer solutions, it cannot be 0, right? So we should write here x is greater than 1, y is greater than 1, and z is greater than 1. And that is also a pretty simple problem. You already put 1 1 1 in these three variables, and you have basically the new equation is x plus y plus z is equal to 2007, and you solve this equation instead, and the number of solutions will be 2007 plus 2c2. So that is 2009 c2, right? 2009 C2 solutions, which you can calculate, and that is coming out to be 2009 into 1004. These are the total number of solutions such that they are positive integer solutions to this equation, right? Obviously, we don't care about just that case. We have to ensure that x is less than y, less than equal to y, and y is less than equal to z, right? So we'll divide the problem into three cases. Case 1. Case 1 is when all three of x, y, and z are equal, right? Suppose we do the case where x is equal to y is equal to z. Obviously, the answer will be 670, right? 670 into 3 will give us 2010. So there is only one solution in this case, right? Only one solution in this case, correct? Case 2 is the case when 2 of x, y, and z are equal, right? 2 of x, y, and z are equal. This can happen in these ways. This can happen in these ways. Basically, x is equal to y and z is greater than equal to x comma y. Then x is equal to z and y is greater than equal to x comma z. And finally, y is equal to z and x is greater than equal to y comma z, right? All these three cases are possible, right? So let's find the total number of ways in which x plus y plus z will be equal to 2010 in these three cases, right? So let's take the first case where x is equal to y. Let's say x is equal to y is equal to a and z is equal to b, where b is greater than a, right? Where two of them are equal, right? Here actually we should think about it as greater than, because if z is equal to either of x and y, it will become this case, case 1, right? So if I have this situation right now, then what we have, the equation is 2a plus b is equal to 2010, right? because x and y was A and z was B. Obviously, there is a very easy way to count the number of solutions possible. Here we can say that if B is 2, A is basically 1004. B cannot be 1. B cannot be 1. Why? Because then 2A will be 2009, but this side is even and this side is odd. So that is not possible. 2A cannot be 2009, right? So B is equal to 2 is the first solution and A is 1004. Then B is equal to 4, A will be 1003 and so on till B is equal to 2008 and A will be equal to 1, right? Correct. This is the final answer. A should be 1. So there are total 1004 solutions here. 1004 solutions. So A values were what? A values were the values of x and y, and B values were what? B values were the values of z, right? And there are 1004 solutions here. But here there is one special case that we have to ignore or exclude when A is equal to B is equal to 670, right? When A is equal to 670, for example, you will get 2A plus 670 is 2010, and basically you'll get A also 670. So that comes into the first case. We have already counted that case, right? So I will not count that solution. So therefore, there are 1003 solutions here, right? 1003 solutions possible, correct? Okay. So there are total of, here we had done cases for this, right? So there will be 1003 solutions here, 1003 here, 1003 here, right? So total, there are 3 ways in which this can happen, and total number of solutions is 3 into 1003, right? Ultimately, in the final analysis, we have to ensure that x is less than y is less than equal to z. So we will take cases where y and z are equal. We'll only look at the third case. Y and z are equal and x is less than y, right? So out of these 3 solutions, we'll look at only one set of these solutions, right? So what I'm trying to do here is enumerate the different ways in which x, y, and z can exist. And the third case is basically x, y, z can be all different, right? Can be all different. And obviously, if x, y, and z are all different, you can permute the number of solutions. Basically, what I mean by that is if you create an ordered triple of x, y, and z, there are 6 ways for x, y, and z to exist among themselves, right? So suppose x is something, y is something, z is something, that we can arrange x, y, and z and they can take alternate values and still x plus y plus z will be equal to 2010, right? So there are 6 ways to do it. So the number of solutions when x, y, and z is equal to 2010 and x, y, and z are all different, if that is k, we can basically arrange them in 6 ways, right? So the total number of solutions of the equation of x plus y plus z is equal to 2010, where all of x, y, and z are greater than equal to 1, should be equal to solutions from case 1 plus solutions from case 2 plus solutions from case 3. What is this case 1, case 2, case 3? Case 1 was when x and y and z are all equal to each other. That was only one solution. Case 2 was basically 1003 solutions where 2 of the numbers were equal, right? And there are, the 2 numbers can be equal, those can be picked in 3 ways, right? The unequal number can be picked either x or y or z, right? So you get 1 plus 3 times this plus 6 times k. Why? K was the number of solutions here when x and y and z were all different, and then we could arrange x and y and z among themselves in 3 factorial ways. So this is 6k, and we have this equation that 1 plus 3 times to 1003 plus 6k should be equal to, we had found earlier this was 2009 C2, right? So I'll write the equation here. It was 2009 C2, the value was 2009 into 1004 is equal to 1 plus 3 into 1003 plus 6k. And from here, we can get 6k value. You can calculate that 6k value. And finally, k value comes out to be 335671. I have done the calculations. You can check it yourself. This is the number of ways in which X, Y, and Z are all different. X, Y, Z are all different, right? Correct. So the total number of positive integer solutions that will satisfy X is less than Y is less than Z. This can happen in one way where X and Y and Z are all equal. Another way when two of them are equal and third one is bigger. So that will happen in 1003 ways. We have already done this case. Two of them are equal and third one is greater. And finally, when all three are different, that will happen in these many k ways, right? So that will be 3, 3, 5, 6, 7, 1. And that adds up to 3, 3, 6, 6, 7, 5. That will be your final answer for how many ways in which X is less than Y is less than Z and X plus Y plus Z should be equal to 2010. Right? So what we have done here is basically understood the problem and broken it down into three mutually exclusive cases. And we are saying that the conditions of the problem can be satisfied when you take all different, two alike, and none, all of them alike, right? And if you count the number of cases possible for that, that will give you the final answer, right? Hopefully, you have understood the solution. We'll continue with more problems in the next set of videos, and please, if you like the content of the channel, please subscribe to the channel and share it with your friends. Hopefully, other people also will find it useful. And I'll see you in the next video.